Starting here, we have the repeated zero. So in example 3a, we had that negative 2x squared equals 0 as one of our factors. So we said that 2 of our answers was 0 because when we took the square root, we end up with x squared equals 0, and we take the square root. So technically, 2 of our zeros are at that 1 point because we'd have a plus or minus. So let's go ahead and apply a few of these or all of these characteristics that we've talked about. So sketching the graph of a polynomial function is not always easy, right? Because the higher the exponent, the more turns, the more that's going on. So we can sketch this, an emphasis on sketch, and that it's just going to be like a rough drawing, by doing these 4 steps. Apply the leading coefficient test. That will tell you what happens on each side, the left and the right side. Find the zeros like we just did. Plot a few additional points using a table of values by choosing x values between the zeros. We'll do that. And then draw your graph. So let's start by the leading coefficient test. I'm going to go ahead and number these steps so we can match them up. So number 1, my leading coefficient is positive and the exponent is even. So that means if you look back that you're going to have a graph that rises to the left and rises to the right. So that's what the leading coefficient can tell us. Now let's find the zeros and then we'll apply this to our graph as well. So let's do number 2. The zeros. So if we take our function up here, it looks like we can factor out an x to the third. So we can do x to the third. That leaves us with a 3x minus 4. That will equal 0. And then if we set each piece there equal to 0, we'll get x to the third equals 0. So here we would take the cubed root. Now here, that means that x equals 0 3 times. So the multiplicity there is 3. 3 of our zeros are at the same point. So there's one of our zeros at x equals 0. And then if we set the 3x minus 4 equal to 0 and solve there, four thirds. But when we graph this, we want to think about it as a decimal. So that's about 1.3. So in this case, whenever you're graphing, decimals are going to be helpful. And then there's our other 0, and that multiplicity is just 1 because that's just x. It's not x squared or x to the third. So the multiplicity there is 1. So there's our zeros. So now that we have some actual values for the graph, let's go ahead and start our sketch. So our zeros are 0 and 1.3. So I'm going to come over here and just start a little sketch. My zeros aren't very large, so I'm going to go ahead and just do -1, -2. Oops, that's positive there. So think about the scale of your graph when you draw. And then our zeros would be at 0. So I know it's going to cross here. And then about 1.3, so 1 1/3, it'll cross there again. And then remember we said it's going to rise to the left and rise to the right. So that means that on the left side it's going to increase and on the right side it's going to increase. Now I don't know exactly where those go yet until I get a few more points, but I do know that that's the direction it's going to go. So now let's do step 3 and plot some additional points. And when you're figuring out what points to choose, you're like, well, I don't know what points, what x values to pick for my table of values. Okay, look at your zeros. So I'm going to use our graph. And I want to have values in between those zeros and maybe even one on each side. So I want to pick a number off to the left. I want to pick maybe a couple numbers in between, and then also a number off to the right, so I can really estimate what that graph is going to look like. So because there's not a lot of space in between our two zeros here, I'm going to go ahead and choose 1/2 as one of my x values and then +1 as one of the x values, just because they fall in between my two green points, which are my zeros. And then I'm going to choose -1 as an x value. And then I'm going to do 2 as an x value. And let's see what we get. Now, maybe those aren't great points to choose based on our graph, but I'll show you how to tell. I'll show you how you can tell if they're good or not. So we said, make a little table for x and y. You can make it up and down, side to side, doesn't matter. But we said in between our two zeros, we're going to choose 1/2 and +1. And then to the left, we were going to do -1, and to the right, we were going to do +2. So when you fill in these values, then all you're doing is using your calculator and using your function. So remember, our function was 3x to the 4th minus 4x to the 3rd. So on your calculator, you're taking 3 times 1/2 to the 4th power, always substitute in parentheses. So if you type all of these values in, for 1/2, your y value or your output would be -0.3. For 1, it would be a -1. For -1, it would be +7. And for 2, it would be +16. Now, these two fit on our graph very nicely because our graph only goes to 2. These two, however, are pretty big numbers. So let's try, instead of using these two, so here's an example where 7 and 16 maybe aren't the best. So instead, let's do -1/2. Let's change these by 1/2. Instead, let's do -1/2 and then 1.5. If we do those values, for -1/2, we get 0.7. So that's on our graph a little bit nicer. And for 1.5, we get 1.7. And that's on our graph much nicer. So now we can use these points and plot them. So we said that at 1/2, we were at -0.3. So at 1/2, we were at about a -1/3. So I'll just put that point over my 1/2 mark there. And then at +1, we were at -1. And then we had at -1, we were all the way up. So at -1 here, we would be all the way up at 7. And we said we didn't want that. So instead, we did -1/2. And at -1/2, we were at 0.7. So almost 1. And then at +2, we said we were at 16, which is way up there. So instead of using that one, we did 1.5. And at 1.5, we were at 1.7. So about right up here. So my lines were close. So now that I have these, I can connect my points because I know, right, from here it's going to keep increasing and rising, and from here it's going to rise. That's what we use our leading coefficient test for. So sketching this, I'm going to erase my estimations. Takes a little bit longer on this program as compared to Notability. There we go. And then connect them with a more smooth curve. So I know that, remember we said at -1, it's going to be all the way up at 7. So I know here that's going to increase quite a bit. So I'm going to make that pretty steep. And then I'm going to connect. I'm going to go down and up. Make that a little bit smoother. There we go. And then again, remember we said at 2, we were all the way up at 16. So that tells us that this line is going to go pretty steep as well. So there's just an estimation of what the graph looks like. I could probably make that a little bit smoother here. There we go. But there's how we can sketch a graph using the leading coefficient test, real zeros, and then a table of values.